Okay. Hello, everybody. We are here for our weekly Wednesday with an amazing speaker, Vera Serdiukova. I'm pronouncing her name right, I hope. And we have an exciting topic about AutoML and AutoML on the edge. And Vera comes from experience building products as a product manager on the doing AutoML on the edge. And I'm going to let Vera introduce herself. But I just wanted to ask the class one thing. Remember, we've been talking about AutoML for a little while, and there was one discussion in our AI class. I always, whenever we hear any of these tech topics, I ask you to think about your role. So as you're listening in today, even think about, okay, if you're going to be doing product management or whatever your function is, and make sure let's keep it interactive so you can chat your questions, and then I'll be fielding the questions back to Vera. She's very open to have a conversation. She's going to share some slides but said she can have a discussion. Okay, so I remember one discussion was when we have mobile machine learning on the mobile, right? There was one example of translation that Google has and Apple has, and one of them does it on the edge and one of them does it on the cloud. And we had a discussion about what could be the business consideration, what is different. So I don't want to take time away from Vera, but I want you to think about it because I would like to know if you remember what the difference is. And then we've been talking about how we have so much connectivity and there are so many cameras out there. So if you are my AV student, you're going to be thinking about the car, like I would think as the edge device, but cameras could be edge devices or it could be an IoT, it could be anything. So with that, let me pass it to Vera. And Vera, can you just tell us a little bit about your background, because we like to know the person holistically, and then you can teach us something about AutoML on the edge. Thank you so much.
Absolutely. Yeah, and first of all, thank you so much for inviting me to be a part of this discussion. I'm really looking forward, to sharing a bit of my experience, but also, helping you guys better understand this space and especially the aspects that are more relevant to your role, or your aspirations. So yeah, just a couple of words about myself. Currently, I work as an AI product manager for LG, the big international corporation headquartered out of Korea, but really present pretty much in any country in this world. And here I work as in the field of edge AI that we define as on-device machine learning. And I build products with an amazing team of AI scientists, machine learning scientists, engineers, UX designers, so really interdisciplinary team. In a little bit, we'll show you a bit more about, the specifics of projects I'm working on. But just to give you a bit of idea of where I'm coming from. So before LG, I was with Bosch building products in the field of conversational AI. So speech-enabled interfaces for robotics, connected car, and smart home. And before that, I was in slightly different roles, so primarily business and corporate development, also connected cars, so envisioning experiences, products in the cars of the future, as well as other less high-tech, I would say, industries. So also doing business development there, identifying product development opportunities, and translating things like potential partnerships into opportunities for my companies. So yeah, I would say overall fully business background. And it's been really exciting to explore the field of AI ML over the past 6-7 years and really see it come, out of academia and translate into real products that companies are investing in and that the users are benefiting from.
So you took my AI class, right? Not the AV class.
I did take the IoT class a few years back. Yeah, I think that was perhaps 5 years ago, 4 or 5 years ago. Yeah.
Fantastic. And you were on the BD side at that time, if I remember.
I was actually doing project management for conversational AI. Yeah.
Okay, perfect. and it's a great trajectory, even how you've gone through your career. I'm sure people will have questions about that. So let's dive in. Thank you so much.
Yeah, absolutely. So as just to set the stage, shall we watch a quick video to
Yes.
give you guys an idea of
Yeah.
why LG deals with Edge and AutoML and
Yeah.
All right, let's do it. So
Yeah, you can share the screen. It should be fine.
just give me 1 second. All right, let me play a brief video for you guys. And please let me know if you cannot see it.
LG's customers are engaging with our smart connected devices at home, in the workplace, and on the move. These devices are made smart using AI models developed in and deployed from the cloud. But these devices are also less personal because their smartness comes from data aggregated from many users. Now, LG is exploring a different way to be smart, one where personal data never leaves the device, where learning happens continually on the device. The consumer gains a private, personalized experience tailored to their unique lifestyle needs. This is the promise of Edge Learning. With Edge Learning, LG's products will continue evolving long after they leave the factory. Refrigerators can recognize items and learn usage patterns unique to your lifestyle. Washers and dryers reduce vibrations and optimize spin cycles for your specific installation and load. Robot vacuums will continually learn how to efficiently adapt to changes in your home. The advanced AI team at our America Research Center creates building blocks to enable Edge Learning at LG. We are developing AI algorithms that support learning on devices where compute and memory are limited and labeled data is scarce. Optimizer, our open source model optimization tool, simplifies and streamlines the tedious and time-consuming aspects of building models for the edge. By combining in-house and external best-in-class capabilities, Optimizer allows our AI practitioners to focus on only the most innovative aspects of building models for the edge. With Edge Learning, LG can offer customers a smart future, one that's more secure, with learning happening on the device itself and delivering an entirely personalized consumer experience. Edge Learning, more personalized, more evolved, more secure.
All right. Yeah, so as I promised, it was brief and hopefully gave you guys, a bit of visuals to connect the dots and a bit of background to understand, what context my team and I operate in. So yeah, this video touched on a few aspects of my team's work, that is end user edge applications, as well as underlying core ML infrastructure, so AutoML infrastructure for actually building such applications.
That was definitely helpful. The one question that remains is, if you're doing it on the edge, you're keeping the data on the edge. So the data is not going to the cloud. I got that message. But how do you build? Because you need a lot of data to build. So do you tell us a little bit more about the AutoML aspect of it? And you have a slide share, I thought.
Absolutely.
Okay.
Yeah, so there are, I guess there are a couple of questions we can break it down into. So first, let me just make sure that all of us are on the same page. So I don't know how much you guys know about Edge, but very briefly, it's a very novel, I would say, nascent field, especially when it comes to AI on the edge. And there are a lot of different definitions in the field. So everybody, when you say edge, the probability is high that everybody will have a different understanding of what it is and what it is not. So just for the purpose of our discussion, we define edge device as a device whose compute, memory, and energy resources are constrained and cannot be easily changed. So if you think in the context of LG, that can be, for example, a smartphone, it can be For example, an appliance such as a smart refrigerator, a robotic vacuum cleaner, right? So think in the context of such devices. Again, in other domains, the definition might be slightly different from a teeny tiny sensor to say a network edge. That is, a completely like a 5G network edge. That is a completely different story. So we won't be touching on that. So for LG specifically, we see, I would say, we come not necessarily from the technology perspective, but from understanding the needs of our users, right? Before we start building the products, before we start building the applications. And what we have identified is that depending on a specific target customer segment and of course, the application, there are a few needs that current AI/ML applications have troubles meeting. And roughly speaking, they fall into 5 groups. Those are autonomy, speed, accuracy, security, and privacy. And what I mean by that is that when you think of traditional AI/ML, as Sudha has mentioned, most of the times they depend on cloud connectivity. So say, if you are in San Francisco Bay Area, you're driving down Highway 1, you don't get any network, that's it, right? Your AI/ML powered application cannot be running. Also, that brings in the aspect of latency, of course. The dependence on the cloud usually means that you have to send the data to the cloud, get the result, get it processed there, get the result. So, it takes a bit of time. If network is involved, latency impacts user experience. You cannot get results as fast as you might need to. Then accuracy, as we talk about user data, right? A lot of times you want to adapt application to the specific user needs, meaning adapt it to their data, for example, to their preferences or how they're using the device. That brings in the aspect of customizing the application. You could do it on the cloud. The problem with that, if you have to customize a machine learning model that powers this application to every single user, scalability becomes a problem, right? Because then you have to manage thousands, perhaps millions of individual models on the cloud. Then there is an aspect of security. Essentially, if there is something like a hacker attack and you have this centralized engine running on the cloud, and it is attacked, then all of your users are attacked and are impacted by that. And of course, privacy. And I guess that goes to the core of Yosuda's question, right? If you have private data, and this aspect is becoming more and more salient to our users around the world, with our with the devices we use every day, like your smartphone, there's so much information about you that is being collected. And what we see that the users are becoming very sensitive to how this data is processed. So providing AI/ML capabilities on the edge where the data never leaves the device really allows us to enable this this value of securing the privacy of user data. But of course, these benefits sound great, but as we have mentioned, there are quite some limitations to building AI/ML applications on the edge. So if you think of any device, there are the 4 key limitations, compute power and memory that tend to be limited on devices, right? And that's why cloud is such a go-to tool, right? Because there you have this elasticity where you can scale those. On device, you don't have this freedom. And another major limitation is data. So what I mean is that first of all, if you do collect if you collect data just from the individual user, this data is pretty small in size, right? Most of the modern AI/ML applications rely on data from many users, hundreds, thousands, and that allows you to build this AI smartness. Then another challenge related to data is data quality. Because if the data does not go to the cloud, you have limited ways to prepare it. So, for example, to either clean it and I should say label it, that might also create limitations. But again, when we talk about building applications for edge AI, some of those limitations might be more or less relevant depending on what exactly you are trying to do, what device you're trying to do, what user experience you're trying to enable. So for example, depending on whether you're just trying to do the decision-making inference part of the process on device, or you're trying to do the entire pipeline, so training and inference of the machine learning model, the consideration for these limitations would be very different. So I can talk about different aspects of enabling, of kind of thinking through the processes depending on the application you have in mind.
There's a bunch of questions. If you don't mind, I can.
Yes, let's do that.
So Richard is asking what kind of applications do you do? And he's interested in VR. Is VR something you can do on the edge?
Right. Yeah, so just a small disclosure. I won't be able, to talk about like all the work we do at LG and my team is involved in, just because, it deals with future product development, products that are not announced, ones that are not announced yet. So I won't be able to talk about it, but let me just talk about it more from the industry perspective and, the experience, the things I have seen over the past few years. So edge in VR is definitely one of the most promising domains and applications. If you're familiar with companies like Magic Leap or Oculus by Facebook, those are perhaps some of the most outspoken proponents of using edge for VR. And there are a couple different ways you can think about it. One is perhaps more obvious, like processing the content, right? Like the core capabilities of VR. But that, interestingly, I see less of. Perhaps, of course, there are just higher requirements on the horsepower, the device horsepower. Even though I'm not really an expert in VR, I cannot speak on that much. But what I find interesting is that there is really an investment into doing edge for interactions with VR assets. So you can think of, for example, gesture controls, haptic controls, as well as voice controls to interact with the device or with the content. And that is using edge. And I would really recommend looking up both Magic Leap and Oculus for specific applications. But that's where we see a lot of activity. So really enabling, human-machine interfaces. And the advantage of doing edge there is, first of all, really providing this smooth, low latency interaction that does not depend on network connectivity. And that's really crucial for VR experiences, right? You don't want any friction introduced with just because of connectivity issues. So that's where edge seems to be working really well.
That's interesting that it is a business trade-off, because there's a question about that, saying what are the different business trade-offs?
Mm-hmm.
And that is something that I'm interested in. But I want to get to specific questions that people are asking about privacy. Emmanuel has a question about when you're saying data is on the device and the machine learning happens on the device, will the user get access to the data, or would user just get the experience of what the results from the machine learning model are?
Right. That's an excellent question. Thank you, Manan. I would say it really depends on your application. So let me give you a couple of examples where the data can be visible to the user or not, as well as the results. So I'm not sure how many of you guys are on Android. So the most popular mobile OS in the world, right? And a few years ago, Google has introduced this capability in Android, where it can help you extend the battery lifetime using training at the edge. And the way it does it is that it learns how you use your Android device, whether that be a smartphone or a tablet, which applications you use, how you use them. And then it uses this knowledge to moderate how the applications are running in the back of your device. So if you have this functionality activated, and of course, as a result, you have a longer battery life on your device. That is awesome. So this is an example of functionality where most likely you have no idea that this edge-enabled capability is happening, how it is happening. You don't really see the data that goes into this learning. You don't really see the results of this capability, of the scoring capability, right? What you see as the user is that, okay, your device just runs longer. So that's an example of this, I would say, more obscure edge AI/ML powered capability. But then there are other cases. For example, many of you might be using, for example, photos like Google Photos or Apple Photo applications, right? And one of the capabilities they have there is clustering pictures based on people's faces. For example, you can you can easily find pictures that feature you, or I know your family member or your puppy, right? And this is so they're also doing it at the edge. That's an example where you as the user might be involved into the process. Sometimes they would ask you, for example, is it is the person on this picture tagged correctly, right? So you would contribute to building this capability. And you also see the results, right, where the pictures are clustered by the people on them. Yeah, so that's a slightly different way to present the results, and also to collect inputs for the application. So it can be all across the range, from something completely obscure to the user to something very visible and the user actively contributing to building and improving the application. I guess the bottom line, it really depends on what your objectives are when you build the application, what experiences you're trying to enable for the user, and what the requirements are. Because sometimes you really have to get your users' input to build a valuable and viable application.
So Jonathan is asking, is this doing some kind of transfer learning? And also he adds that on the Android keyboard, it is learning locally, but he has a concern. Does that mean, data is being sent to the cloud? So
right.
From your photo example, it is not sending the photos per se. It's not my family photos, but the overall learning that goes with it is sent out to the cloud across multiple devices. So overall, their facial recognition algorithm gets better. Is that true?
So so first of all, excellent question. And we're touching on a couple of different aspects here. So for the photos, honestly, I don't know both for Google Photos and the Apple ones. I'm not sure of the entire pipeline they have. So I cannot speak on what exactly is sent and is not sent. So I won't comment on that. For Gboard, what they are doing there is something that is called federated learning. Yeah. And that is slightly different. So what it means, and there are there are a few different modalities of federated learning. But what they're doing in this case is they basically built, think of it as building many individual models, right, for individual users, and based on individual user data. And then they send in these model modifications to the cloud, where they use this information learned from individual users to build a new, better common model, right? Unified model that is later sent to the users, and that is then updated by each individual device for each individual user. And then again, they send these updates to the cloud, and then they modify, then they use this knowledge from many users to build a new, better model that is then again sent to the users. So the difference there is that they don't send your data per se, like they don't send, the messages, for example, you type in using Gboard, but they are sending model updates that, does not, for example, contain the content of your messages. It's really just, a piece of a model that they send to the cloud.
So the federated learning earlier has been done across industry level. So, different banks could arrive at their own fraud protection models or fraud detection models, and then they combine and share it at the cloud. So now a single company could do that across multiple users, just for its betterment of its own algorithm.
Right. And another great example of that, that I guess is really at the intersection of business and what we call AI for good, is using federated learning type of edge AI for medical applications. And where it really shines is, for example, the breast cancer detection. There is a very interesting project. You guys check it out. It's by NVIDIA. They have a platform called Clara, and they had multiple medical institutions, so hospitals, research institutes, run this core that is, federated learning core to detect anomalies on mammography scans. So, trying to detect various, potential cancer, other sort of diseases.
Yeah.
And they were doing that individually on their proprietary data, right? We're talking about medical data that is highly sensitive, right? That's not something you want to share. So they were doing it locally on their proprietary data. And then, so building their kind of proprietary models on this data. And then again, they were sending these models to be aggregated and to build a new, better, improved model that, as they proved, happened to detect this sort of anomalies significantly better than the individual models. So this way, they bridge the gap between using large data to train good models. Of course, usually, to train good models, powerful AI applications, you really need large, high quality data. So on the one hand, they managed to bridge this gap between the data and privacy. In the end of the day, they were not sharing their patient proprietary data with other institutions. So I think that's one of the great applications, and we'll see more of it in the years to come.
So what is AutoML about it? Because AutoML is kind of touted like it is no code. And recently we have a class called Capstone Lab AI, where everybody is learning how to take a business problem and arrive at a whole model like a sprint as a multi-disciplinary team. And we used Auto AI from IBM, and they have federated learning also on the edge. We've not done federated learning. Tell us a little bit about Auto AI to get us on the same page.
Right.
Your Auto AI on the edge specifically.
Absolutely. Let me just quickly go back to the presentation. So yeah, just before we start with the whole topic of edge AutoML, let's again make sure that we are using the term the same way. So I define AutoML relay software that can automate single or multiple processes within the machine learning pipeline, right? And the reason I want to mention this definition is that AutoML is, is such a burgeoning field, and there is so many different understanding of what AutoML is and is not. A very common understanding, so as you have mentioned, is this one-click solutions, no-code solutions, right? That allow you to build the entire that allow you to automate the entire machine learning pipeline and get pretty much a ready-to-go model, if not the if not the application from just with one click. This is one side of the range. On the other side of the range, you have something way simpler, tools that can automate just teeny tiny piece of the machine learning pipeline, for example, hyperparameter optimization or data labeling, and that would also be called AutoML, right? So there are really a lot of different understandings of what it is, and the truth is, it is both. It really just depends on who you talk to. So why AutoML? Why do we deal with AutoML, and what is the confluence of Edge AutoML? So as I have mentioned, for LG really sees HAI-enabled applications as the way to enhance the experiences of our users, right? And there is quite a bit of priority going into building on the edge. However, the thing is that Edge AI/ML is very new, and it's really not trivial. As I mentioned, there are quite a few constraints, right? Building for limited data, for the devices where memory, compute, and power are constrained. So though this is very different from traditional AI/ML, and by traditional, I mean, cloud-based AI/ML, where you can rely on these gigantic models, right, that do the heavy lifting for you. So building for the edge is really not easy. And what we as the company have realized that it's a lot of techniques, so a lot of processes and infrastructure and plumbing is just not built for to enable developers building edge AI applications. And a lot of work that would help them is actually academia level. It's not industry grade. And what I mean by that is that, for example, for somebody trying to build an application for Edge, they would perhaps need to go through dozens, if not hundreds, of research papers and GitHub projects to get to the result they might want to get. What it means is that, first of all, it's incredibly tedious, right? It's very time consuming. Like, we're talking perhaps not just weeks, but months of development time that of course has a huge business impact. Of course, it extends your time to market, right, for your product. Also, we have a problem of reproducibility. Of course, a lot of times this academic work and GitHub projects, they're not built to automate industry-grade, production-grade product development. So, once you use them, you cannot, a lot of times you cannot replicate the results, for example, or you cannot scale them to multiple applications. So we saw a lot of these issues arising within LG, different business units building Edge AI applications. So what my team and I are doing in collaboration with a couple of other teams, we want to understand which processes of building AI applications for the edge can we automate, what best practices exist in the field, how can we automate them, how can we make them really production grade, in order to get rid of all of those trade-offs that I've listed, tedious, time-consuming work of going through research papers. So we don't want our AI developers dealing with that. We want them to focus on really the most fun, the most innovative parts of work. And that's where we started building this essentially internal tool, internal AutoML tool that helps them to optimize models for the edge and build the models for the edge.
Jonathan is back on the transfer learning part. So he's saying, if you're going to learn a user's behavior from their data, or in your LG example, you're saying what's the vibration data from a particular device, so you can optimize that device. But when it gets to a user's personal device and understanding their behavior, his question is, it has to overfit for that user. So it learns only from that user's data, and it knows exactly what the user wants because it's using their data. So it is going to give the right response, and it's going to work perfectly. But if it is, unless it's overfits, then it is going to transfer the personal data. It's going to send personal data information out to the cloud, wherever it it aggregates the federal learning. This question is about, again, on the privacy, how much of the customer data is actually sent in the form of learning. It's like sending anonymized data, right? It still invades privacy if you're going to send anonymized data across a bunch of data. Have you seen that in your discussion?
So let me just quickly distinguish a couple of things here. So first of all, I guess for the sake of kind of the group understanding, I'm not sure whether everybody is familiar with transfer learning. So the way it works is that you have one common model, right, and then a bunch of learning model, and then you send it to multiple users, where this model learns additional data from your users, and it adapts this base model to the information from your users. So the core knowledge is kind of the same for everybody, but then there is this additional layer of knowledge that is learned from the individual user data. And so this is slightly different from the federated learning. And I don't want to go to the technicalities here, but one thing I want to mention is that federated learning is also just one type of a bigger group that is called collaborative learning, right? And there are just so many different techniques, right? And so many different variations of collaborative learning and federated learning per se. So depending on the technique you select, the technique would define what exactly you do on the edge versus on the cloud, and what exactly you're sharing, right? So I guess whether you are sharing just model updates or you're sharing some user data would depend on the type of collaborative learning technique you pick.
Yeah.
However, one thing I would like just to show out here is that actually transfer learning is perhaps one of the most commonly used way of learning or training at the edge. And that's something that many, if not most of us, actually use in our day-to-day life. So for all of you guys who have, for example, iPhones and that are using Face ID, where you can log into your phone by looking at it, that is powered by transfer learning, right? So you have this model that has been the base model that has been trained on faces of hundreds, thousands, millions of people, right? That was pre-installed in your phone. And then when you activate this capability on your iPhone, you go through this enrollment process where it learns your individual face, right? And it adapts this base model to your face so that it can recognize your face. So this data about your face biometrics stays locally on the phone, and it does not share it. Other similar applications that also use transfer learning are, for example, voice ID. Some of you might have it with your bank. Bank of America, for example, used it for a while, where your voice would be used as your signature. Essentially, they have this model of voice recognition as a base, and then they would adapt it to your proprietary voice, and it would be used as the way to authenticate you. For example, when you're calling Bank of America, they would authenticate you just based on your voice. So I would like most of these transfer learning techniques done on the edge, they really don't show, they don't share your proprietary data. But one thing to remember is that, again, transfer learning can also be done on the cloud, right? So when we say transfer learning, it does not necessarily mean learning at the edge. So there might be some overlap here, but those things are not equivalent to each other. Just like when we say federated learning or collaborative learning, some things might be done on the edge, some things might be done on the cloud. It's very rare, I would say, in industrial setting, almost never, that absolutely everything is done on the edge, just because it is not practical.
So Jonathan here is actually a data scientist, and he's been typing a lot of questions. So Jonathan, can you just speak up and ask your question? Mm-hmm. If it's relevant to this flow, she'll answer now, otherwise we'll table it and come back. Jonathan?
I cannot hear you. You might be muted.
No, he's not yet speaking, I think. I'm not hearing him either. Oh, Jonathan is speaking. Okay, I'm just going to make you co-host temporarily so you can speak up and if there is any issue. Jonathan, we can't hear you at all. No, it's still we can't hear. Oh. Yes.
Okay, sorry. If for some reason it doesn't work, and my external sound card. Sorry. Yeah, sorry. So yeah, I wouldn't call myself a data scientist, by the way, but I do have a background in AI, so I'm familiar with these terms. Mm-hmm. I'm a service designer, so I'm coming much more from the user and business perspective. I guess that's kind of more what I'm interested in, and perhaps something you could speak to is not so much like the technical details of how, the difference between transfer learning and federated learning, for example. I understand that, and probably some of the people in the call, have an understanding of that. But for the average user of, say, a smart home device, how can we explain to them, or how likely do you think it is that they would understand how their data are being used or not being used? And how does this relate to this kind of balancing act that every business that's using ML is playing between, if we get more data, we can potentially build a higher quality model, right, versus maintaining the required level of privacy that the customers demand. And as you said, that might shift over time as consumer preferences change. But how right. do you kind of make that balance in LG?
Right. That's an absolutely magnificent question, Jonathan. And I wish I had, a simple two-word response to it. Unfortunately, I don't. So let me just kind of share a few things that I guess I've learned over the years. One thing, the rule of thumb is maximum transparency with your users about what data is being collected and what it is being used for. And I think the industry is getting significantly better with that. You see it like, I would say voice user interfaces and voice-based devices tend to be more obscure about it. Just because, the way people perceive information, the visual-based applications tend to be better with it. So for example, if you're using Google Maps or pretty much any other application, right? And now when you enable new functionalities, for example, location history, it would tell you what you would get in return for enabling this data collection, right? For example, it will provide recommendations, right? Or it will provide the history you can look up. So data transparency and communicating that to the user at the right time in a really digestible way is really key. This is one thing. And I believe it also helps to build trust, and trust is really critical for any application, right? Especially the applications that people tend to interact either in the most in the most private places or moments of their life, right? Whether those are their home environments or private data, for example, related to your health, right, or your activity. So building trust is really important. Another thing here is understanding really your data needs. I guess for anybody, working in AI/ML, there is this feeling that, the more data, the better, right? We can build better models, we can perhaps enable more capabilities. But I think what is becoming not just more obvious, but also a legal requirement is really only collecting and processing the data we must collect and we are authorized to collect and process. And we see that with things like GDPR, for example, right? So I think being more deliberate this way and being very thoughtful of what exactly you want to enable and how can you achieve it with as little data and, little not necessarily in terms of size, but very kind of targeted type of data is something that is helpful. And for example, you see giants like Apple and Google really cracking on that, right? Where every time you download a new application, they tell you which data from, for example, other applications it would be pulling from, right? And they tend to call applications that really harvest data from too many unrelated applications. So I guess we'll be seeing more of that. So it's very important to be deliberate about collecting only the user data you need, right? And informing them about it. And last but not the least, helping the users understand the quality of the data. So one thing, communication, I think that really helps. Another thing is really, I think, building brand about it. That's the new thing we see happening. For example, Apple is a great example. If you are here in the Bay Area, you drive Highway 101, you see these gigantic billboards everywhere that say privacy, right? And they really tell you how they're using every part of their stack. Would that be, the hardware they're using, or, a specific application, like, for example, Face ID, to enable privacy. So really centering your brand around careful treatment of user data, privacy, I think helps to promote these capabilities and actually, make your users turn them into your advocates.
Yeah, I think Apple and Google give useful examples of two different approaches in some way. In that Apple is very much going down the privacy route, but that actually limits the amount of data that they have to train their services, versus Google for a long time has been offering services like Gmail for free if you give it all of your email data, and photos, unlimited photo storage, right. Obviously doing lots of machine learning on that. Facebook probably going even further. But yeah, it would be interesting, I guess. Maybe different customers will go to different brands. I suppose if privacy is important, they go to Apple. If you prefer free, more powerful services, you go to Google. But I guess it's a gamble that every company needs to take.
Yeah, segment is a huge part of the game. Another big question is, what exactly are you trying to do for them, right? What makes sense for this application? I think like a couple of years ago, with the whole revolution around edge AI, there were proponents of doing edge only. And I think the time is showing that it's not very sustainable. You just have to understand what works best for a specific, application or experience you are trying to enable for a specific group of users or customers. And I see edge versus cloud just as, a set of tools, and pick, the one that makes more sense.
I remember, Vera, in the early days of our IoT class, the one you were involved in, we had this edge versus cloud discussion as if it's either or. I remember Tesla does that. Tesla says they send the data to the cloud from all the different cars, but they also do some edge learning. So they kind of have a hybrid approach to that.
Yeah, I've also heard that. And I would say that's perhaps the most common way to do that.
Okay, so we have 5 more minutes, actually 3 more minutes. If there are any last minute questions, maybe, do you have a specific topic or comment that you want to add? Then you get to close out, or we can see if there are more questions, because people will hear longer.
Yeah, let me just mention one thing to you guys, something that you can also check out. So unfortunately, I cannot share the entire, internal HTML work we're doing. HTML platform we're building internally. We did open source a part of it under the name Optimizer. It's on GitHub. So just Google GitHub Optimizer or just Optimizer. And this, the open source project presents, snippets of the work we're doing internally, but it might help you understand, what aspects, what considerations of building models for the edge we can automate using AutoML tools, and what benefits it brings to our users that tend to be machine learning scientists, machine learning developers, AI engineers. So things such as, for example, hyperparameter optimization, then understanding model performance on device without actually deploying them on device, converting models into various formats. That is very important, for the edge. Of course, it depending on, what format is supported. So these are a few snippets of, edge AutoML work we're doing internally, but I guess it can give you an idea of the needs that edge AutoML developers have and how they can be addressed.
Perfect.
And if you have any additional questions, just please feel free to contact me over LinkedIn. Usually I'm pretty good in responding, so I'll be happy to continue the conversation.
Perfect. Emmanuel has one question, like a comment, I think. So if there is learning that's happening on the edge, do companies actually offer that as an additional service? So with IoT, we had all this discussion about business model, that we are not going to sell product, but we are going to sell more data-driven services. Does it lend itself to it now that we can offer learning?
Right. So I would say monetization is something, and building business models around edge is something that is still in its early days. But I would think about it from a couple of different perspectives. One is the benefits, such as, perhaps not monetary benefits it can bring to our users, and thus differentiate your product, right? So example we discussed earlier, Apple, if privacy is the benefit that really is the quality that really differentiates your product, perhaps that's something that is not necessarily a direct revenue channel, like training at the edge is not necessarily a direct revenue channel, but it enables you to position your product such that you can sell more of it at a premium price. So that's one way of looking at it. Another way of looking at it is cost saving, because AI/ML tends to rely on cloud, right? Whether you're doing it on AWS or Azure, or whatnot. And while in many ways they democratize AI/ML, as you scale, costs really pile up. And in fact, running AI/ML applications, especially when we talk about, for example, having multiple models, adapting models to users' environments, that becomes very, very expensive. So if you can offload it to your users' devices, run these computations on their devices as opposed to AWS, you're actually saving quite a bit. So again, that's not necessarily a revenue channel, but you'll see that in your bottom line.
It's fantastic. So I think we are at the end of our, I said edge, since we have been talking about the edge, we are at the end of our session. But this has been amazing. Thank you so much, Vera. And Vera is ready to connect with us on LinkedIn, so hope people will connect with her. And this recording will get posted on under Career Pivot on Driverless World School, so you can go take a look at it and bring your friends to come look at it. Thank you.
Awesome.
Everyone.
Yeah, and thank you so. Yeah, thank you so much for having me over, and I really enjoyed the conversation. I know it's not the most trivial topic, and perhaps, not something that most of you deal with in your day-to-day, but I hope, you got something out of it, and please feel free to contact me if you have any more questions.
So people are chatting and they're saying thank you and great session, interesting discussion. Thank you so much. Thank you
Awesome.
Thank you so much, Vera, and hope you'll come back, because a good discussion, a good topic, a good speaker is one who makes us think and come up with more questions. So you've done that for us today.
It's my pleasure. It's my pleasure.
Thank you so much.
Yeah,
okay.
You guys stay safe, and take care. Bye.
Okay, bye.
Bye.
Bye.